As Sumit has mentioned, we started the initiative in 2010, and I guess over the last 12 months we're really excited about what we've been able to achieve. So what I wanted to do today was just briefly take you through some of the key things that we've landed in the last 12 months. And through the presentation, or through the conference, we will have some more detailed presentations and workshops to sort of explain the details of those. But one of the things that I wanted to really do today was just perhaps explain some of the broader industry benefits that are being delivered by the initiative and some of the challenges that we've actually been able to overcome over the journey. The other thing that I'd really like to do today is to talk about some of the lessons that we've learned through effectively this first generation of projects that we've delivered using building information modelling and digital construction. We've finished this first wave of projects, and some of those are very significant, like the Darling Harbour Lives and the Barangaroos. And we've learned a lot of lessons from those projects. And as we move into this next sort of major construction wave, we think that BIM-MEPAUS is really well placed to help the industry deliver that next round of work. One of the things that I'd really like to do is just to really acknowledge the contributions of everyone to the initiative. We've had great support, not just by businesses but by individuals, and it's through that we've actually been able to get to where we've got today. So, in terms of the agenda, I'll take you through the template and some of the workflow enhancements that we've been able to make with Autodesk, but also just talk about some of those broader benefits that I was mentioning. Then I'd really like to focus on some of the key lessons that we've learnt around integrated project delivery. So for our overseas visitors, when we talk about integrated project delivery, we're not really talking about a form of contract, we're really talking about this integrated workflow from design through to construction through to the delivery of an as-built model. And finally, I'd like to talk a little bit about building lifecycle data and where we see that heading, particularly over the next 2 to 3 years. So that's the broad agenda. Jumping into the template first. In terms of the template, I suppose there's 2 levels to the template. There's that technical BIM component, but really the thing that I think differentiates our approach to templating is that we've really tried to address all of these broader industry sort of objectives in terms of this development of a national template. You know, we really, from the start, we wanted to focus this constructible modelling, and I think globally we've been recognised for our leadership position in that. But the other thing is, you know, at the start there was a lot of talk about what does open mean. So open for most people means, well, it's got to be something that's interoperable between software platforms. What we've done is still can be converted out to an IFC and exchanged that way. But I think our definition of open is somewhat different. Our definition of open is nothing is locked in BIM-MEPAUS. So for a very modest fee, you can buy into the template and you get all of the benefits of the development. And the other thing that we were very focused on is this: it's got to be usable by the majority, because that's the only way that the industry is actually going to develop capability. So I think now what you're starting to see is the real benefits of the approach that we've taken in terms of the template, and I'll perhaps run through some of those in a minute. I was looking around for a curve to sort of explain the benefit of the template, and I came across this blog which was basically why BIM is sending your firm bankrupt. But the thing was that here, this is quite good, because actually what it does is it says that an investment in a template, and this is talking about a business, but when you talk about it as a nation, investing in that template delivers efficiencies all the way through the design documentation process. It also sort of indicates that that move of focusing into the design and the virtual build process ahead of the construction. But as I said, probably Australia is unique in terms of this national approach to a MEP template. But I guess a lot of people have asked us, why does it take so long? And I think until you've sort of really got involved in it, and you start to understand some of the challenges that have had to be overcome, it's not surprising now that it's taken us so long. So to perhaps just explain a few of those things, industry standards, just how hard could that be? Well, when you go and look at ductwork, one of the things that you find is that ductwork, everything starts with a coil width, and when you look in Australia, you couldn't actually believe that even though we went metric in about the 1970s, that there are actually 2 coil widths. So, to actually standardise on a national template, you've actually got to standardise the industry on a hard metric coil width. So to get some of the country's biggest duct manufacturers to change their coil width, that's almost the first thing that they've got to buy into. You look at something like internal linings and acoustic insulation. So this is a chart that we did internally within Coombs, and the dotted blue line is about the average of what the consultants were specifying in terms of acoustic performance. The solid lines are the products that were available in the market. The interesting thing is that really, probably the only range that really matters when it comes to building services is probably that 63 to 125 hertz. The other thing about it is that when you look at the specifications that you receive from designers, they specify in excess of 72 different products. So the inefficiency that produces within the supply chain is just enormous. 72 different combinations of densities, thicknesses and facings. So what BIM-MEPAUS has done is get that down to basically 9 core products. And of those, about 6 would meet 80% of the industry requirements. So some of these things take quite a bit of time to actually work through with the industry to work out what to do, and then to actually get it into a template and a specification. And then there's a process to get the consultants and the industry to adopt it. But the benefits of these sorts of efficiency gains are huge for the industry, they're huge for the client, they're huge for the suppliers, they're huge for the subcontractors. And then that, not only do you have to have the stocks at the suppliers, you've got to have the stocks at the manufacturers. So again, when you went down 5 or 6 years ago to some of the big duct manufacturers, they were almost drowning in different insulation products that they had to have on hand for those small jobs that come through. Modelling standards. How hard can that be? Now, I'm not going to put up... one of the things is that in the business I work for, I see a lot of tender documentation coming through our business. And one of the things that's certainly happened over the last 6 to 7 years is that there's been a huge divergence in terms of documentation standards in the industry, because there is no real defined, until BIM-MEPAUS came along, defined standard about how you should represent things. Now, I'm not going to put up all the different consultants' models, you just have to trust me, but it is a kaleidoscope of colours, shading schemes and all those sorts of things. So when you look at a model from a consultant, you go, well, what am I really actually looking at? And it varies everything from just a single monotone colour through to just this incredible matrix of sort of colours. So, one of the things has been that we've had to sort that out. And it's interesting because even some of those things are not that easy to sort out in terms of how they appear in, say, white versus black, different screens, and just getting clear separations between the colour palettes. How hard can it be when it gets to things like BIM standards? And this is a particular nightmare. So some standards are just almost unknowable. So, you think that to go and find a reference set of shared parameters, say that for Kobe, now, you know that they exist, Search for them in Google, can't find them. Search for them in Building Smart, can't find them. Dive into the deep web, get all these crazy people trying to contact you from Russia, these Russian girls, I don't know. Try explaining that to your wife, get out of that. Trouble, all right, so you go, oh, I can't go there. So you get out of there, sort all that stuff out. When you do find the stuff, it's incomprehensible in either that it's so complicated it might serve a purpose for the programmers, but for the majority, it's very difficult to understand, or it's very broad. The other issue is often conflicting terminology. So terminology that the industry uses is not the terminology that, say, the BIM programmers thought might be sensible when they were setting up the standards. And trying to, say, merge, one of the biggest things, merging design and fabrication, man, what a nightmare. So it is unbelievably stressful to try and work those things out. And finally, when you look at a lot of these standards, they actually tend to conflict and compromise what was a good established practice. And particularly things like LODs have really distorted our understanding of how to deliver projects well from an integrated design and construction perspective. So what have we done? We've developed effectively about 23 specifications so far. This specification is probably the core and most difficult specification of the whole bunch. This specification represents about at least $2 to $3 million worth of development work over the 5 years. Right? You cannot believe how much time it has taken to develop this specification. But what this has enabled in the industry is just huge, because what it enables is designers to share resources, contractors to share resources with drafting firms, supply chains to work efficiently together. And so a lot of the firms who've contributed it are now starting to see real value out of it. So one of the things that's central to BIM-MEPAUS is this idea that we're going to connect systems, services and specifications. So Revit out of the box, it's got supply air, return air, exhaust air. We've effectively got 12 standardised systems based on Australian standards. We've got standardised colour coding, and those colour codes sort of make sense intuitively. So greens are the sort of the outside airs, blues are the conditioned airs, the reds are the returns, the ambers and the oranges and the sort of yucky colours, they're sort of the exhausts and hazardous exhausts and things. The other thing that we've got is we've got basically 5 standardised services. So these are the standards that the ductwork systems get built to. To do this has been a huge challenge. To actually do this, we've actually had to increase the quality of the duct and the ceiling to get this level of gain. And again, trying to get a business to say, you've got to actually build a better quality duct to build more efficiently has been a huge challenge. But for those firms that are adopting it, they're really starting to see significant benefits. So this is a real milestone, and in terms of all of that, a big thank you to the ACCI in terms of just helping, particularly over the last 12 to 24 months. It's allowed us to get these 23 specifications up and guidelines and to refresh our website. And there is really no other resource that I know of, like the BIM-MEPAUS website, in terms of industry resources that are free. So, and interestingly, I've got a few people to do searches not in Russia this time, but in the UK and the US and all sorts of places. And even from their particular workstations, BIM-MEPAUS is just about the first or the second hit when you do that search on BIM-MEP. In terms of the pipework side of things, we got this done fairly early in the piece, and that was a really strong working relationship with Victolic, where we sorted out the gapping and all those sorts of things. And Victolic have taken all of these standards and development and doing some really good things with it. But it's really powerful when you can model like this and deliver like that. Because what this allows you to do is to do all those sort of safety and design reviews, look at buildability and do all those sorts of things really effectively, and then it's just a matter of delivering it then on site. The really big thing that we've achieved this year, and particularly with the release of the 2018.1 Revit, is that we've got this integrated workflow now working really well. So this is, I think it's the sample model. This is at schematic design level, so really good from an engineering perspective around doing those system designs and calculations and checks. Flipping out to what most people would think would be LOD 200 and a bit, but I can look at that and I'm going blue's conditioned air, and the duct is blue and the service is blue. You can see the hatching pattern tells me it's internally lined. Red's the return airs. So all of that's very clean, and if you compare that to old sort of modelling standards, very lean. From there, we can now, through this design to fabrication, because we've built the standards the way that we've built them, we can flip them out to fabrication parts, and it's a very close one-to-one translation. Okay, and that's a shop drawing now. It's very lean. There's much less markup needed because so much more information is embedded in the parts. From there, you can do your reviews in Navisworks, and again, much more effective in terms of design reviews. You can look at things like accessibility. You can really do really good quality design reviews, approvals using these Navisworks models. From there, we get to export that into CamDuct, and again, we can review the model, do a final check before we push it out to fabrication. So here, this is down at Duct Makers, but ultimately what we've been able to demonstrate now is this, from the start of design through to something coming out of the coil line, it's all fully integrated, seamless workflow. And that's where that about $2.5–3 million worth of investment's being made in terms of developing standards, bringing constructability into design. And if you're a consultant, you know, you often talk about getting early input of constructability advice. There's a hell of a lot of that advice and learning built into the template now. And if you've got the really good gear, you can start to do these sorts of things. So this is laser cutting ductwork, and what this allows us to do is to actually start to build really, really tight ductwork, really advanced components that can go into systems that we've never had the capability before. So this is the sorts of efficiency benefits that we're starting to see through the industry and innovation. So you might say, that's all very good, Warwick. You've just shown us a tiny little fan coil unit. I'll show you something at scale. So this is O'Connor's at the Health Innovation Building for the Uni of South Australia. This is a full fabrication parts model, fully exported to not one, but two fabrication shops. And what's really interesting about this, and so people say, well, why should builders care? Why should clients care? Because when you look at the enormous, the tight program that Hansen and Youngkin had to deliver this, the ability to share capacity across different supply chains, because you're building on a common standard, delivers huge benefits to the builder, delivers huge benefits to the client in terms of getting their project delivered on time. The other thing is that what's proven from this project is because we've upped the standards across the board in terms of all BIM-MEPAUS duct is pressure class A sealed, that the actual ductwork leakage on this project, which I think the industry's learned duct actually can leak quite a bit, or significantly exceeding DW 143. So that's it actually delivered. And you can sort of see the complexity, the coordination processes and all that. And on the left, you can see the Revit as-built model. So that's not fabrication, that's not CAD, that is full BIM delivered. So, people are starting to really see benefits in terms of the workflow and the standards. The other thing is we haven't lost the scheduling component of Revit, which is really good. And also really good in terms of how things like dampers and those sorts of things have been set up in terms of creating penetration drawings and all those sorts of things. The other thing though is that because we've been able to link Revit to fabrication, when it comes to actually value engineering, it is actually a huge investment, but when you get this SMEP linking fabrication, linking supply chain, real economics and real pricing, you really start to be able to value engineer very effectively. So one of the things here is you see is a design that's been optimised using absolutely known costs per duct. Okay, so the costs that are in this model and what we're fine-tuning are based on real costs of delivery. It's not dollars per square metre. We know exactly how much the different components cost. Here is it's a plant room, and we're going through an exercise in SMEP in terms of actually optimising that design to maximise not just the performance of the system, but obviously the installed cost as well. So that's on the MEC side. The other thing that Sumit mentioned, and Tim's going to be giving a more detailed presentation on the integration of BIM-MEPAUS into PowerCAD. So PowerCAD is the platform that the majority of Australia's consultants are using for electrical engineering design. And we've had really good engagement with PowerCAD. And we've had really good support from the consultants in terms of getting these new standards up and people like Nielsen. So we're thinking that this is going to progress pretty quickly. And I'll let probably Tim explain a little bit more about that later on. The other thing around our strategy is obviously there's the template and the IFMs. We've sort of done our first generation of IFMs and a lot of that work is actually available in the Australian Autodesk content pack, but we really want to get these IFMs to the next level. And now that we've sort of got ductwork nailed, this is where we're probably going to be focusing a lot of our effort. But really, when you look at the template, one of the key benefits of the template to the industry has been that it's enabled the majority to get into BIM, okay, in a way that lowered the costs, lowered the difficulty, lowered the complexity of working in BIM, and it's probably no other country, I think, has benefited in the way that we have in terms of a national approach to the template. So that's around the template, and you'll be hearing lots about it, I'm sure, through the course of the forum. In terms of integrated project delivery, this is the slide by Carl Agar that goes back a fair way and everyone's sort of pretty familiar with it, but this concept of a single model that's developed from design through to construction and handed over as the as-built model. We sort of simplified it a little bit to this concept of there's a design model, whatever degree that gets built to. We then go and virtually build it, and we use that construction model to deliver the project physically on site. And from there we get this as-built model. This is what we saw in 2010 from Arabs, and this is only about 2 or 3 years after Revit MEP came out. And you could immediately see the benefits of BIM and where it was all going. But the fact is the industry really couldn't do that much with it at the time. This is the sort of tender documentation. I just did a quick scan around our office over the last month or so. But you look at some of the modelling that's coming out from some of our consultants using the template, and it's just incredible. So, you know, you look at something like the FLOF model for the cooling towers and what you can get. So you can get not just the cooling towers and the spatials and the pipework setup, but you can also get all of the safety and design, the maintenance access, all those sorts of things. And if you're a client getting that type of model, you're pretty confident about what's got to be delivered in the construction phase. Similarly, on the right-hand side, we've got some big extraction systems. But again, you can see all of the maintenance and access provisions modelled in there. This is probably, in my mind, one of the best examples of integrated project delivery. So CSL are really known to be a tough client, but Irwin Consult used the template. This is almost at LOD, about 500 what was being delivered. But one of the things that people think is that what they're saving is redocumentation time. The real value in this is where you're able to actually get a really good model and really start that virtual build process and work out how as a team you're going to deliver the project effectively. If you get something and you've got to muck around with it and a whole set of drawings and trying to understand what you've got to do, you're wasting really valuable time and opportunity. So from that, you can build it and you can deliver something like this. Okay? So from a client's perspective, getting a model that's rendered like that can be hugely valuable in so many different ways. You can access training, all those sorts of things. And there was virtually no wastage on that project. There was no redocumentation. There was no trying to relearn what was the consultants already knew. And that allowed us to really focus on delivering value to the client. In terms of the construction sector performance, really interesting. So a lot of people have onboarded in Australia, probably more than many parts of the world, this idea that the consultant model will get passed forward to the construction team. And we've delivered this first big wave of work. But there are some real lessons that have been learnt. It's worth putting things into context a little bit. So Alan Wahar got up last year and talked about this UK industry performance report. And those sort of numbers, you know, he's saying, well, what sort of industry accepts that? What he did mention was that there was about a 35% reduction in waste since 2010. What he didn't mention was that margins in the UK have actually halved since 2010. The statistics for 2016 have varied a little bit, but probably not statistically significantly. My feeling is that we're probably there or thereabouts in terms of industry performance. This is just something I came across my desk last week, and this actually says that the major contractors, their margin last year was actually minus 0.5%. And some people are thinking that's good, they're getting value, but clearly that's not sustainable. I don't know actually how anyone could think that's good. But anyway, moving on. Then a really interesting report came out by the firm last year, or this year, and they actually had some quite interesting insights. So from the Australian perspective, evidently Australia really uses PPPs more than just about anyone else, which really supports this integrated project delivery, and probably the best case studies in integrated project delivery are in that PPP environment. I didn't make it up, what they said was also that in terms of one of the big problems was the competitive procurement environment and how that was perhaps leading to some fairly dysfunctional outcomes. I wasn't so keen when I read this. So what they're saying here is that evidently a whole lot of the problems are due to dysfunctional subtrades, but what they did say then was that they thought there was a 50 to 60% productivity improvement. From there, what they did though was they did identify these things. And what you can see is that BIM-MEPAUS speaks to a lot of those key improvement factors. So what are some of the lessons learned through this integrated project delivery, this first round of work? So one of the things that we really do need to rethink about is what are the design deliverables. So we're seeing some fantastic modelling now, and that's really great. But when a lot of people now in their BIM execution plans are using LODs, and you know, it always used to be around the chair, and then someone's gone and put a boiler in there. But you can distort a lot of really good practice. around deliverables. So asking a consultant to deliver a clash-free model, complete waste of time, because you're going to convert it out into whatever you're going to go and buy. What you really need to know is that model has been coordinated and it's constructible. So I went and did a bit of a check on documentation that's come through our office in the last 6 to 12 months, and virtually none of them have what is absolutely essential, which is this seaming coordination plan. In the time that we've been using BIM more and more, it's amazing how, in some adverse sort of way, bizarre way, we've actually had some really major coordination issues, because these sorts of fundamentals that were established best practice in the 1990s have got lost in the journey. So not only do you have to have that, and there's actually some fundamental issues in that one, but I won't go into it. But the other thing is that then there's traffic lights. So who gives way to who when it comes to coordination? And what is the coordination sequence that's to be applied? So we really need to rethink that. The second thing that we really need to do, and often this is actually going back to the clients and the project managers, is we actually need to look at the engagement of the design team. So often there's this thing, well, we'll go and get less of the consultant and save some money, and we'll give it more to the construction team and they can do more. But if you're going to go through that virtual build process, you actually need the architect and you need the structural engineer there, because you can't build without keeping the model in an architectural and building trades and a concrete sense up to date. So we really need to refigure that. And Alex, who talked to us a few years ago about New Horizons, really explained on that project how well it worked, where Lyons, who were the architect and the structural engineer, stayed involved in the process. We need to make sure that the design and construction management are fully integrated and fully committed. So often there's, we want BIM, we want this, and pretty quickly it gets washed down. And then what that all sorts of leads to is these sorts of issues. You know, you get back to the old paradigms of poorly coordinated installations, you get to lots of duct wastage. Now, notwithstanding that those skips are A.G. Coombs corporate colours, that is not an A.G. Coombs project, all right? Just so we don't get in trouble. But the thing is, each piece of duct, and I think that's stainless steel, each piece of duct there is about $1,000 wasted by the time it gets repaired. So you're looking at about $50,000 worth of wastage in that skip. So the real message is you've got to commit to the strategy. The other thing that is interesting and problematic as to why do you get a return on BIM is the consistency of the implementation. So what you see is some of the big contractors, I'm doing it on this, but I'm not doing it on that, even though we're all going to do it on everything. But other contractors are really, really committing. Like they turn on their screen and it's all digital construction. That's what they see, that's what's in their face every day. We need to move our mindset from, still you see a lot of BIM execution plans, they talk about coordination process. We've got to change our mindset to we've got to get the virtual build done ahead of the construction cycle. You know, where this was really successfully done on the Telstra project, and what you saw on that site was that the project was clean because deliveries were arriving just in time, things were coming and going up. It was probably one of the safest sites that you've ever seen, and it was one of the most effective sites. So when you see it done really well, you really understand the value of this virtual build process. The other thing is it allows integrated prefab, and so you can retrofit prefab. This is the Barangaroo job where we delivered the integrated services risers. But one of the things that happened on this job was very early day discussions around how we were going to integrate this prefabricated solution into their core. If you're retrofitting that, it never works as well. Finally, we need to make some shifts in terms of time, cost and value. So the thing is, we need to value good design. That's not 100% defect or clash-free. We need to value and understand the value of that virtual build, and we need to deliver and move more of the effort into that process so that we spend less time and resources and reduce our risk on site. And there's still, I think, some learnings. And what's interesting is that the US is probably heading more back towards more design development before they put it into the construction system. So moving forward, we know that we've got a really big construction wave coming up. I really believe, because I do see a lot of projects, both internally but also in sort of the advisory stuff I do, where you see this process working well and where you see the commitment is where you see projects really kicking it out of the park. And what BIM-MEPAUS is doing is supporting that delivery. The final thing I just wanted to talk about briefly was building lifecycle data. We need to really, as an industry, resolve what we're doing. So we need to resolve what's going in the model in terms of data. We need to actually move more to technical scheduling in terms of specifications and the like. So, you know, if I say looked at Oricon and what they're doing, they're moving more and more of the specification into their schedules, and that's a beautiful thing. Okay, because it gives you all the parameters. There's no guessing what power factor this has got to be or what how this transformer's got to work. What's interesting is that those sorts of schedules are matching up pretty closely to the BIM-MEPAUS schedules. And what we also need to do is work out a little bit better what we're going to deliver to the asset and facility managers. Just some general observations. We need to go from building information modelling to building information management and work out what that broad set of records is that we deliver to facility managers. And really it comprises those construction records, it comprises data and it comprises models. Those models, I don't think we've really quite got our head around what that needs to look like at the moment. One of the things that we're seeing, and AG Coombs has a big service business, is that what's been delivered out of the BIM process is not what's been needed by these really big property portfolios. So particularly we do a lot of work in the tertiary education sector, and what they're asking for now is just about every contract, and it's same in the commercial, is that they're asking for a lot of asset management analytics, a lot of operational analytics, and what we're delivering as a construction sector to support that is a mismatch. To get those two aligned costs a lot of dollars. Depends if you're owned by the Japanese yens or the Spaniards by euro dollars. But we need to sort this out because this is going to be a really, really big thing moving forward. Didn't see much for quite some time in the asset and facility sector. Now it is all about analytics. And we need to be delivering something that meets that requirement. So that basically what they look like, I'm not quite sure, but that's something that we need to figure out. And we really, actually, in reality, cannot deliver what we delivered in 2016-17 in 2020-21. So those projects starting now have to have a really good understanding of what's needed for asset lifecycle analytics. Where we're going to support this is around the naming conventions and the shared parameter scheme that's accessible that people can find, and also defined naming syntax that a lot of good work was done by ANSYS and we're embracing. In terms of where we think we are, you know, it's been a long journey and people ask why does it take so long. I think we think that we're actually in a pretty good place and moving forward pretty strongly now. Where we think the building data is that's going to be a fair bit of industry challenge over the next 2 to 3 years, and hopefully we'll get some answers about what we need to be doing at the forum. In terms of the roadmap for the next 2 to 3 years, a couple of things. We're going to build out the EMP and also the F. The fire, we know a lot of progress is now being made with things like AutoSprink and HydroFlow or HydroCAD, and we've got some pretty good libraries in that. So we'll get that going up pretty good quickly. The IFM library we actually think is quite a challenging thing, but we're going to get that done. We're going to complete the naming conventions and those things, and we're going to get, we think the other thing that's really big is the content strategy. So starting to see some really big movements in terms of content. and I think it's going to be a very different place in 2020 in terms of content. So to finish, hopefully we've been able to give you some insight into where BIM-MEPAUS fits, not just in terms of BIM, but the industry. We're pretty excited about the progress that we're now starting to make. I think the other thing is that, and Alistair McDonald said, is that really BIM, when it was Balfour Beatty, said that for them, BIM was their innovation platform. And I think, you know, where we've come, you can really sort of start to see that being delivered in spades. So there's a lot of work still to do, but we've made some good progress. So thanks everyone for the support today. Thank you.